morning. Today my topic is network topology. Under that network topology, I am going to explain the basic definitions and main definitions, tree and co-tree. So what is meant by network topology? Network topology is a graphical representation of electric circuit. It is useful for analyzing complex electric circuits by converting them into network graphs, and network topology is also called graph theory. So that is a main use of this network topology. So it is useful to analyze complex electrical circuits. So that is a main use of this network topology, and this is also called graph theory. And here you can see there are some network graphs which are shown. First one is a T topology, and then that is how it is represented. Then you can see the H topology representing a electric circuit, graphical representation. Then second one is a H topology, and third one is the pi topology, which looks like exactly the symbol pi. And the next one is box topology, and then next one is you can see down L topology, and then C topology, and then twin T topology, and then twin T topology drawn as a bridge. So these are the some network topologies. Next, what is meant by graph? So graph is here exactly to say it is nothing but a network graph. So it is simple, in a simple manner it is also called graph. It consists of it consists of set of nodes which are connected by branches. And here what is meant by node, what is meant by branch? So a node is a common point of two or more branches, and sometimes only a single branch may connect to the node. So that is a node. So node is nothing but it is a common point of two or more branches. Sometimes one single branch also is there which is connected to the node. So that is the node. And then what is meant by branch? Branch is nothing but it is a line segment, that connects two nodes. Okay, so that is a branch. Then now, how to get the graph for a given electrical circuit? How to get its equivalent network graph? So here that is what it is mentioned here. So any electric circuit or network, okay, can be converted into its equivalent graph by replacing passive elements and voltage sources with short circuit and current sources with open circuit. Okay, that is a point. So if suppose the electrical circuit or network is given, we can get its equivalent graph by replacing voltage sources and passive elements. Passive elements means R, L, C. So resistor, inductor, capacitor, so which may present in the given circuit. So all the passive elements and voltage sources replaced with a short circuit, and current source replaced with open circuit. Okay, so that is how graph is obtained. Then here finally what we say is, that means the line segments in the graph represent the branches. Okay, the branches corresponding to either passive elements or voltage sources of the circuit, actual circuit. So that is how a graph can be obtained. An example here, see that given electrical circuit has a voltage source 20 volts, battery 20 volts voltage magnitude, and these are the different resistors present. Okay, 5 ohm, 10 ohm, 10 ohm, 20, and on the top we can see 30 ohm, and on the other side there is a current source. So this is a given electrical circuit. Now how to get its equivalent graph. So here we know that graph means basically it consists of nodes and branches. So to draw its equivalent graph, okay, so this is how it is drawn. So we need to identify the nodes present in the given circuit, nodes present in the actual circuit. Okay, take the same number of nodes, okay, in the graph also. So first you need to identify in the given circuit how many nodes are there. So we know that what is meant by node. Basic definition for node is a common point in the electrical circuit where more than two circuit elements are present. Okay, a common point where more than two circuit elements are present, then that is called node. So here you can see from starting from the source, voltage source. So first point, if you see this becomes one node, first node, let us say, and then this will be also one more node, let us say node 2, and then next point also one more node. Yes or no? Because there are more than two elements connected at this junction, at this point. Okay, so that's why 10. Okay, so what are those elements? 10 elements, 10 ohms, 20 ohms and 30 ohms. So this is node 3. So then if you see the next point, this is not a node because only two elements are connected. Not even two elements, only one element, that is current source. So this is not a node. Down also not node. Now this is you can say, okay, this is also a node, and this is also a node, and this is not a node. Now this point and this point, okay, so both are nodes, but this point is same as this point. Why? Because there is no element in between them. There is no element connected between them. So these two are considered under one node only. Let us say already we have given we have the nodes number 1, 2 and 3. So let's say that this is node 4. Okay, so finally in the given circuit, how many nodes? 4 nodes. So take the same number of nodes in the graph also. So node 1, so this is node 1, node 2, node 3, node 4. Okay, so the same number of nodes. Okay, same number of nodes to draw the graph also. So we have to take. So that's why it is represented. First mark the nodes. Now draw the branches. Okay, draw the branches. So we know that how to get the branches line segments. So we know that just now in the previous slide you have seen, we have to replace voltage sources and passive elements with a short circuit. Okay, and current source with open circuit. So that's why so start from node 1. At node 1, what are the elements connected? So if you see at node 1, it is connected to, from node 1 to node 2, one element is there 5 ohm, and node 1 to node 4 voltage source is there, and node 1 to node 3 30 ohms is there. So that's why, okay, the 3 elements, whatever, one voltage source and 2 elements, those are replaced with a short circuit. So see that, you can see this is one line from node 1 to 3, and node 2 1 to 2, this is one more line segment, and node 1 to 4 third line segment. Okay, so now, okay, I will tell you how it is given. The line, the branches, the branch, you can see the letters, English letters A, B, C. Okay, I will tell you. Usually the nodes are represented with the numbers and the branches represented with the alphabetical letters, small alphabetical letters. Okay, nodes represented with the numbers and branches represented with the alphabetical, small alphabetical letters. Okay, that is how it is used, and some textbooks vice versa also they take. That means they represent the nodes with the small alphabetical letters and branches with the numbers. That is also okay. That is also taken. Different textbooks, that is how they take okay representation. So here I have taken nodes to represent the nodes numbers, okay, and branches to represent the branches. I have taken alphabetical letters. Okay, so here you understood. So how from node 1 how the all the branches are drawn. Next, from node 2, so you can see in the actual circuit, okay, node 2 is connected to node 1, node 3 and also node 4. So all the passive elements. So that's why you can see the lines, branches from node 2 to the okay whatever the nodes I mentioned just now. Now next, coming to the node 3. So at node 3 you can see it is connected to node 2 and node 1 and also node 4. Node 4, okay. So 10 ohms is taken, okay. Node 3 it is shown. Then node 3 to node 1 it is also shown, and node 3 to node 4 you can see there are two elements. One is 20 ohms and another one is current source. So this is a 20 ohm resistor, okay, which is replaced with short circuit, and we know that current source is replaced with open circuit, okay. That's why it is not there in the circuit, okay. So finally, that is how the graph is completed. Drawing the graph is completed for this given circuit. So here how many branches? You can see there are 6 branches. I have taken branches are A, B, C. Randomly we can take. So I have started from up. Branch A, branch B, branch C, branch D, branch E, branch F. Okay. There are 6 branches. There are 6 branches. Now you can see how many nodes and how many branches in the obtained graph. So here the nodes in the graph is same as the number of nodes present in the actual circuit, okay. But here you can see the branches. Here one branch, how many branches we have? Only 6 branches, but in the actual circuit there are 7 branches, okay. So that's why because we know that current source is replaced with open circuit, okay. So that is the point. We can see here one branch is less in the okay graph because 4 ampere current source is made as open circuit. Finally, what we can say from this? The conclusion, we can say number of nodes present in the graph will be equal to number of principal nodes present in the circuit, electric circuit. Nodes are same. Nodes present in the graph is equal to number of nodes present in the electric circuit. But coming to the branches, number of branches present in the graph will be less than or equal to, okay. Branches will be less than or equal to number of branches present in the actual circuit, given electrical circuit. That is the final point, conclusion, okay. You have to know, okay. Now coming to the next thing, types of graphs, okay. There are varieties of graphs, okay, which is given as connected graph, unconnected graph, directed graph, undirected graph. What is meant by connected graph? Connected graph means you can see the first picture on the left side on the top. So connected graph means all the nodes are connected with the branches, okay. That is called connected graph, okay. Now unconnected graph, what is meant by unconnected graph? So here in the name itself it is so simple. So unconnected means one node or few nodes, okay, is not connected to the remaining part of the graph, okay. That's why it is named as unconnected graph, okay. All the nodes are not connected. That is the meaning of unconnected graph. Next one is, what is the next thing? Next thing is directed graph. Directed graph means the branches, okay. Directed means the branches are represented with its directions. Okay, so that is called directed graph. So you can see all the branches here having the directions: branch A, branch B, branch C, D branch, D branch, E branch F. Every branch is represented along with the direction. Okay, that means with respect to particular node, is it incoming to that particular node or it's outgoing, like that. Next, undirected graph means its directions are not given, not shown, then that is called undirected graph. Next, subgraph. What is meant by subgraph? So a part of the graph is called subgraph. And here, how we get the subgraph? We get a subgraphs by removing some nodes. Okay, by removing some nodes or branches of the given graph. Okay, simply by removing few nodes. Okay, and or some branches, few branches of the original graph. Now, so finally what we can say, the number of branches or nodes of the subgraph will be less than that of the original graph. Okay, so that is the that is how in the subgraph number of nodes or branches are less than that of original graph. Hence, we can conclude that subgraph is a subset of a graph, original graph. Now, coming to next thing, what is meant by tree and core tree? So they also comes under types of they comes under types of subgraph. So graph means tree and core tree. First, about tree. What is meant by tree? So tree is a connected subgraph of a given graph. Okay, tree is this is important thing because we have problems later based on the knowledge of tree and core tree. So what is meant by a tree, we have to know. So tree is nothing but, that means is the definition, it is nothing but it is a connected subgraph, okay, of a given graph which contains all the nodes of the graph but no loop. It is a connected subgraph. Okay, it is a subgraph of the graph, original graph, which contains all the nodes, okay, without closed path. Okay, that is a definition of tree. Okay, simple. Tree is nothing but it is a subgraph. It is a subgraph of the original graph, which is connected subgraph. Okay, keep that also in mind. Okay, it is a connected subgraph which contains all the nodes of the original graph without closed path. Okay, so that is called tree. And here the branches of the tree are called are called twigs. Okay, now consider here the graph we have previously we have seen the graph what we have. This is a graph, right? So branch A, branch B, branch C, branch B, branch C, E, branch E, branch F. So this is the original graph. Okay, now for this graph drawing the tree. Okay, so knowing the tree definition, okay, this is one of the tree you can see here on the slide. Okay, so see that. So here this is one of the tree. What is meant by tree? It is a connected subgraph, okay, which contains all the nodes of the original graph without closed path. So here you can see this is one of the tree. Yes or no? 1, 2, 3, 4, all the nodes are there without closed path. So there is no closed path here, right? So that's why this is one of the tree. So we can draw another tree also. Yes or no? This is one tree I have drawn for the original graph. This is a original graph. So I have shown in the slide you can see this is only one tree. Okay, another trees, number of trees we can draw. Yes or no? By knowing the definition. Okay, what are those another trees? So you can draw example. I can draw. This is one and this is one tree. So these are number of trees are possible. Okay, but you can see on the slide only one tree I have taken. This is a tree I have taken for example. Okay, now some more information about the tree. This connected subgraph contains all the 4 nodes of the given graph and there is no loop. So loop means closed path. So hence it is a tree. Now this tree has only 3 branches out of 6 branches of the original graph, because if we consider even a single branch of the remaining from the remaining branches of the graph, there will be a closed path. Yes or no? There will be a loop. Yes or no? So here you can see only 3 branches out of total 6 branches of the original graph. Okay. If we consider one more branch, then there will be a closed path. That's why. Okay, now then the resultant connected subgraph will not be a tree. Okay. Now from the above tree, conclude that the number of branches that are present in the tree should be equal to n minus 1. How do you know the branches in the tree? They are telling that it is equal to n minus 1, where n is the number of nodes of the given graph. Okay. So know that finally the number of branches present in the tree, is equal to the n minus 1. Where n is a number of nodes of the given graph. So in this graph we have 4 nodes. Okay, that's why number of branches in the tree is given by 4 minus 1, 3, which is equal to 3. So it is satisfied. You can see only 3 branches. So next about co-tree. So what is meant by co-tree? So the complementary set of branches of the tree is called co-tree. Okay, co-tree means complementary set of branches of the tree. Now, the branches of the co-tree are called links. The branches of the co-tree are called links. Now, what are the links? What is a co-tree? Previously, we have taken the tree is, this is a tree, right? With branches D, E, F. And now the co-tree is given by complementary. It's complementary set. So what are the complementary set? Branch A, branch B, branch C. So to show the variation between tree and co-tree, the co-tree branches are shown with dotted lines. Okay. So you can see here. So branch A, branch B, branch C forms the co-tree. Okay. And the tree branches are shown with solid lines. Okay. Just to show the variation. Okay. Branches of the tree and co-tree. Now, know that there is a general notation. Small l is used to represent the number of links and small b represents the number of branches, okay, present in the given graph, and represents the number of nodes present in the given graph. Okay, so that is how notation is used. L represents links, number of links, b represents branches, n represents small n represents the number of nodes. Okay, now this co-tree has only 3 nodes instead of 4 nodes of the given graph, because node 4 is isolated from the above co-tree. Now, therefore, co-tree need not be a connected subgraph. Know that is a point. Co-tree need not be a connected subgraph. This co-tree has 3 branches and they form a loop. Okay, basically co-tree need not be a connected subgraph. That is a one point. And second point is the branches of the co-tree forms loop. Okay. Now, so that is a point. The number of branches in the co-tree. the number of branches in the core tree will be equal to difference between the number of branches of the given graph and the number of twigs. Okay. So that is a point. Number of branches of the core tree is given by number of branches of the original tree minus, okay, number of twigs. What is meant by twigs? Branches of the tree. So what are the branches of the tree? We know that n minus 1. So that's why here links is equal to branches, total branches minus number of twigs. What is twigs? N minus 1. So B minus n minus 1. What it will give? B minus n plus 1. Okay. So that is a point. So that is about the tree and core tree. Finally, one more point. If we combine a tree and its corresponding core tree, then we will get the original graph. Okay, if we combine a tree and its corresponding core tree, we will get the original graph. So that is what it is shown here. So we have taken with branches D, E, F is a tree and branches A, B, C is a core tree. So if we combine both, we will get the original graph. So that is also the point. So this is a network topology introduction and it's a basic information. Okay, that's all for now. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.